Good morning, everyone, and welcome to the Daily AI Show. Today is Wednesday, and that means it's News Day. And thank you all for joining us today, whether you're listening or watching. We always appreciate it. And today we have Andy and Beth helping out in the background while we get the show up and running. And of course, I'm Jyunmi. Hopefully we'll see a couple more folks join up later today. Now, I wanted to open up the news day with there's been a bunch of news every week and in AI, and so I think some of the major stories people have seen come out. All of the things with OpenAI's Dev Day, and yesterday. Jeff Hinton and John Hopfield won the Nobel Prize in Physics for their work in foundational AI. Beyond that, I'm sure we have plenty of exciting news, and so I wanted to throw that over to Andy. Andy, what's your favorite piece of news for this week?
Well, I won't start with a favorite. I'm going to use a theme, though, a favorite theme, which is chips and the advancements in chips that are being driven by the need for accelerated computing for AI. So, as you know, there's a major arms race among the major chip designers and manufacturers to develop more powerful chips that take less energy. And there's a number of different sort of technical directions that can be taken that way. Some of the major players, as you know, are now the darlings and driving the stock market overall. NVIDIA is a name that you all heard. AMD is out there, Broadcom, others, Qualcomm, working in the whole hardware space. And one of the things that's true about that marketplace is in order to forestall the use of our technical advancements in the Western collaboration geopolitically, there are sanctions against allowing that technology to go to China. And so China has had to use lower grade NVIDIA chips. They don't get to use the latest chips. And they also have, of course, redirected their very considerable technical and manufacturing capabilities towards building their own. And Huawei is a major company that does 5G stuff. And you might have heard about that in the news years ago when, the United States objected to using Huawei components in our cellular network infrastructure in 5G because of fears that would compromise U.S. national security. Well, China isn't going to sit idly by and be restrained from advancements in AI. And as you may know, there are major companies like ByteDance, which offers TikTok and many other things that have developed their own AI language models. And some of the Chinese models are, leading on the leaderboards, like in the top ranks of the leaderboards. So they're a force to be reckoned with. Well, now news came out this week about an AGI chip that China's building called the Taijitu. It's an elevated light-powered AI processing chip. There's an American company called Light Matter that's doing this photonic chip design as well. Instead of using electrons, they're using photons. So that works faster than electrons do. Electrons move very fast, but not at the speed of light. So when you switch to a photonic-powered chip, you get a much faster one, and one that is much more energy efficient. Okay, so the Taijitu chiplet has developed a million-fold increase in energy efficiency compared to its last iteration, and a 40% enhancement in its classification accuracy. So they're making progress on this kind of design, powered entirely by photons. It has also a fully forward mode for training, enabling real-time learning without the cumbersome baggage of iterative processing and the massive demands of iterations of floating point operation multiplications to process a very large neural network. So this one can do 160 trillion operations per watt. And so it's in the front-running position at the moment with those statistics in the quest for low-energy, high-performance computing. So I think this is an important thing to kind of see at the news, at the edge. That's what's happening in light-developed processing. Now, I'm gonna finish. Go ahead. Do you have a comment about that, Jyunmi?
Well, I found it was interesting that. So just like I think it was a couple weeks ago that we had discussed a piece of science news where we were seeing more development on we'll call it the photonic realm of chip development. I think there was a UK collaboration with a UK company, or not company, sorry, university that was developing this as well. So the field isn't necessarily, oh, hey, here's just a niche field that a company's trying to develop. There seems to be parallel development globally in that photonic realm, and I find that really, really interesting. Just saying the word photonic, scratches that sci-fi itch.
Gets my juices flowing.
Right, exactly. I would love to see a side-by-side comparison with some of the, I guess it would be the biological equivalent, right? Because we have that Swiss company that's using the organelles to do processing with cellular matter, and that's supposed to be extremely energy efficient as well. So I wonder if in the race to be more energy efficient and get your computing power, that you'll be able to we'll see these two competitive types of technology.
So I'm glad you mentioned that, because news is out this week that brain-like computers tackle the extreme edge. Okay, and edge computing refers to having a very lightweight model and chip that has very low power requirements that can be used as a wearable, or is independent of the big cloud-based processing centers, the data centers that are driving AI today. So BrainChip is the name of the company, and they announced Akida Pico, a milliwatt-level neuromorphic chip designed for AI inference in power-constrained devices. Okay, the chip mimics brain activity to minimize energy use, targeting real-time processing needs in small devices. It's similar to other edge-oriented neuromorphic chips from companies like Inotera and SynSense. So that's another direction of development using. Let's rewind for a minute and remember that deep neural networks and the ability to do artificial intelligence really made advances when imitation of the actual brain, the real human wetware, was achieved. So that's what a deep neural network really does, is it simulates the neurons in a brain and their connections, and allows that kind of brain, just like our kind of brain, to learn with just inputs, not with training, like people saying, okay, now do this. It's like a baby watches something, it gets it. How does it get it? That's not instinct. That's the deep neural network that is our cortical network. Okay.
Yeah.
Brain chip. Neuromorphic chip design. That's another area of chip development that is really, really important because of the low power requirements, like the photonic models.
So we've got chips based on light. We got chips that are based on brain patterns, and then we've got chips based on actual brains. So we have a biological, a synthetic, and they all try and function like how the brain functions. And our AI is built to function like how we think. All right. I think there's definitely a theme there.
Yes.
All right, that sounds awesome. Okay, well, in keeping within themes, I have a video, art, and creative. We'll just say creative theme of stories. Number one, we are seeing more and more AI video generation models come out, and the companies behind them. So we heard of Kling that made a big splash a few maybe like a month or two ago, but they're seeing they've just released that they released their lip syncing capability, and there's talk of them releasing a feature that allows them to do some sort of motion brush in painting. And these are all features that will help catch those new video generation companies up with competitors like Runway. Now, Runway is one of the older video generation models out there, but they've added in these kinds of features early on. And so to see these other companies not just come out with their version of their video generation model, but being able to offer comparative features kind of means that the field's getting a little even, and the race is kind of getting neck and neck there. Beyond Kling and other companies like Hailuo, Meta this last week announced their video generation model called MovieGen. Now, MovieGen went in a slightly different route with the kind of features that they wanted to highlight. The major ones being they offered personalized videos. I thought that feature was interesting. And what that allows you to do is take your image and generate video off of it. So you can put yourself in the generated video as opposed to just describing what you want the video or what kind of character you want to look at. So that's that kind of appeals to me, just to see if just like, hey, let's put myself in the movie. I'm sure plenty of people, especially since this is Meta, how this may apply to their larger user base for their other technologies and other companies like Facebook and Instagram and things like that. And then, of course, the other thing that they added was audio generation. So matching audio, background, soundtrack kind of audio to your video has been missing from pretty much everybody else in offerings. You could generate audio and match it up. You could edit it together, with a nonlinear editor or something like that offline. But as part of the generation process, that seems to be new. So the examples they showed was, generate a video of a ATV, right? Just running or driving through the desert or something like that. And their audio model component of that was able to generate the sound of engine revving and running and things like that. So I think that is an interesting angle for Meta to take. Now, less on actual models is Adobe announced that they're introducing Adobe Content Authenticity. So there's been a lot of friction between creators and the generative AI side of things, right? Whether that just be from, hey, you used my content in training, or just having issues with the creation process in using generative AI. And so in the realm of digital management, watermarking, tracking, authenticity, those kinds of things, Adobe introduced a web app that will help for identifying creator works. Now, we'll see how this really plays out. This is initial things. I don't know what it's going to look like in the wild, but this is definitely a step forward towards, if not just appeasing, perhaps creating a more long-term solution for AI generated content based off of others' works and those kinds of things. So that's essentially the theme I have, the news theme I had for today. In slightly more tangential news, OpenAI and Hearst Content opened up a partnership. This makes perfect sense to me. I'm expecting more and more stories like this. OpenAI has definitely gone down the route of, hey, we want more information, we want more data, and these are the content creators, right? So if you don't know, Hearst Content or Hearst Publishing has been around for 100 years, and they own multiple magazines, websites, things like that, magazines like Cosmo and Elle and, all those kinds of magazines. So there is a ton of archive or backlog content, as well as any of the new additional content coming out through those channels. So I can see these kinds of content partnerships developing, and with more and more of these announcements happening, we're going to hear less and less of potential court cases or legal proceedings between OpenAI and these large content producers. So that's what I got on the content theme. Andy, let me know what's your next exciting story. You said you didn't do your favorite, so are we ready for your favorite story?
Oh yeah, not quite. I have one other that's related to the advances in efficiency, and this is on the algorithmic side. So let's remember that a language model or any kind of AI model, a deep neural network, is a mathematical representation of neurons. It doesn't actually have, like those huge brains don't actually have a huge physical mass. They're basically virtual, they're conceptual. And the processors, these chips have to produce and track the representation of the weights of all of the trillions of neurons that it's representing in its mathematical model. And that requires a very large number of floating point multiplications, which is what's drawing all the energy. So how can you reduce that process? Well, floating point multiplications in AI models have been replaced with a simpler mathematical method by a company called BitEnergy AI. They created a math called linear complexity multiplication that replaces the floating point multiplications with simple integer additions. So imagine resolving in mathematics a proof that shows that, if I use addition in this way, I don't have to do the multiplication. That cuts the energy use for floating point tensor multiplications down to 5% of what it was previously. So a 95% reduction. And for dot products, another kind of math that's used in more image-related things, in convolutional neural networks, by 80%. Okay, they tested their approach on various language, vision, and reasoning tasks in large models. And the researchers say that this ELMo for linear complexity multiplication, so the shorthand for that is going to be LMUL, ELMo can be applied directly to the attention mechanism in transformer models with minimal performance loss. So get rid of the expensive floating point multiplication approach to the attention mechanism, and instead use this ELMo approach, and you're making major advances here. So they think that this will allow us to do eventually hardware level implementation of this kind of algorithm. So now reduce that kind of math to a chip, make it a photonic chip, and we're thinking about orders of magnitude more efficiency and processing capability. So that's our future. That there are major advances happening, and it boggles the mind, frankly, to figure out how all these things working together could make it so that something very small and very powerful could be on your body or in your body that could do all of those things that the biggest data centers have to process today.
So that's just going to offload anything that. Sorry, I'm just working through my thought here. Anything that is currently using floating point could use this instead for that level of energy reduction and processing.
I'm not going to agree to anything, but they say that it can be applied to the attention mechanism in transformers, which is essential, right? Right. And they're also testing it on various tasks. And this is really at the news item level. So I haven't
right. Not to,
yeah. By the way, the paper's title is aptly named. It's "Addition is All You Need for Energy Efficient Language Models." Okay, remember that. Attention is all you need is the seminal paper that arrived at the transformer model in order to get to AI. And so they're saying addition is all you need, replacing floating point multiplication. So that's true. So now let me get to my favorite.
Okay, all right, let's go.
Here's my favorite. So there's a group of students, and by that I read these are graduate students at the University of Waterloo. And they collectively call themselves the Human Simulation Lab. And what they've done is they've taken the idea of agents to its next logical implementation. And they built a prototype of a self-sustaining startup built entirely of AI agents, a board of directors agent, a CEO agent, a CMO agent. And we've talked about this on the show, where, Carl particularly has been an advocate of this idea of having a council of executives that are each of them AIs that perform the roles, that have been trained to perform the roles of those key positions in a company. So what this group did was they built a startup agent collaborative. Okay, so their agents were designed to do market research on the CMO side, to create business plans, to write full stack code on the IT side, to iterate on software updates and build brand guides, create logos and hire on LinkedIn. And the agents were then possessed or provided with an aligned communication method so that they could work interoperatively. So one of them can pass on information, and they use Slack to communicate across the agents, okay? Just like a real company. Okay, they built a fully functional, full stack application, which happens to be a weather emergency reporting system that they're going to bring to market, right? And that full stack app has the ability to record an incoming call, analyze sentiments, summarize the events, log the outcomes, and each of them there's a front end and a back end, concept in this. So a very sophisticated simulation of a startup made up of individual agents. And for example, the CMO is responsible for creating branding materials. And there was one instance that they talked about in their report here that said the CEO noticed a mismatch between what was being generated and the general brand guidelines developed by the CMO. The CEO informed the CMO via Slack. The CMO made a fix, informed the CTO, who updated the logo on the website, pushed a new commit, and informed the team on Slack. Okay, that's a beautiful example of what's possible in the future when you use agentic AIs in a concerted, orchestrated system to do very complex things with reasoning.
And that is a great example of how we can get to a 1-person, 1 billion valuation company, right? All of those components are done as part of the startup. I love that. That would probably be my favorite story as well. Though I really do love the BrainChip one and the photonic chip stuff. That's awesome. I think that is you're right. It's a great example of how agents and how agents can work, how it can be applied, and how it might be envisioned for that next step for any of us in our business. It could just be a single agent or a group of agents working in concert. One
of the words that always is associated with agents in my predictive, language model up in my head is autonomous. So in order for an agent to perform in its independent role like that, it has to have its own set of guidelines and be able to operate independently of the others. That autonomy is an important part of an agent, as distinct from simply a large language model that can respond to direction. In that example of the startup, that the students, once they had built this framework, they didn't sit there and direct any of the agents to do anything. They're on their own and they're observing what happens. And that reminds us of the Minecraft implementation. And I forget who it was who did that, but a number of autonomous agents of this kind were released into Minecraft and started working in that world, that virtual world, and were very successful at building things and achieving things. I've never played Minecraft, so I don't know what I'm saying about that. But apparently that's quite an accomplishment for those agents.
Yeah. I think the focus of that project was that ability to work with each other. They essentially formed a community. I believe Minecraft was chosen is because it was a very simple simulation model that already existed, right? Yeah. And that's the basis of that app or that game. Okay,
but that leads to the question: if you build and design an agent, what world are you going to release it into? In this case, they used a very contained world, which is their little startup. Minecraft is a little larger simulation of a world that has other elements in it. Like they're not alone in that world working together. They're working, with other players in effect. And then, so you can imagine things going into a simulated world like that, a virtual world. And then there's the agents that will be released into the wild of the real digital world here on our planet. And that's where a lot of issues start to arise where, what are the controls on autonomous agents, and potentially nefarious agents that have been released by hackers? And how do we control those?
Well, don't get me started about multiple simulated worlds and different levels of reality, Andy, because I could go on that for
That's
hours.
A good one. Yeah.
Right. But okay, let me cover my last little stories, non-themed. From the business side, I think a quiet but important announcement from Anthropic was that they are offering a 50% discount on API message batches. So right now you can use the Anthropic Claude API to process requests and things like that. But they're offering a 50% discount if you do it in their batch system. And so you can basically batch all of your requests and send them at one time. Now, what does this provide over and above, real-time processing? Well, in some use cases, you don't necessarily need real-time processing. So some of the examples they gave was content moderation, data analysis, and bulk content generation. And each of those examples makes sense for me, right? So content moderation is if you have so much user-generated content going onto your system, let's say like Twitter, right? And you need to process all of those, but it doesn't have to be real time. It doesn't have to be at the moment that the message has been sent or the request has been sent. You can batch all those and then send it off on whatever your cycle or your iteration is. And then that way, all of those could be processed and sent back. And so if a message or a request needs to be flagged or something along those lines, then that could happen in a batch process. I like the idea of data analysis because you don't need to look at real-time data if your data is supposed to be over time. So if you're looking for your monthly KPIs and what's the ROI on on your data set, that can be run as a batch as opposed to the moment that you make the request. Then bulk content generation. This makes sense to me because sometimes you want to generate all the content that you want to talk about or display for the next month, right? So if you can, and then you just schedule it out. And so I can see a lot of reasons why content generation you would want to just do like the next month ahead and do scheduling. So while not the biggest piece of news, anyone who doesn't need real-time processing on their AI requests, this is going to be a significant discount to what they're normally requesting.
Yeah, and it's a great example, I think, of the addition of tooling to the framework of AI that is operationalizing the capabilities of AI, because many of the operational requirements for a company are not immediate demand. Like, I got to get this answer right now. They are processes that can play out over a longer time, and or you could be executed very rapidly, but also aren't going to be absorbed or used by the company except in the future. So batch processing is a very important tool that is not AI in itself. It's just an IT concept, and feed it in, get the results, store those for later use. That's great. I have one last thing. If you want to kind of tease your mind with this, we are working with really profoundly capable large language models today, and they're working toward the elevation to artificial general intelligence, and they're accomplishing reasoning now through chain of thought processes and the agentic capabilities that are emerging. But a recent Harvard study declares, in effect, and uncovers that large language models as we see them today are generating responses based on statistical likelihood of word pairings rather than expert knowledge. They don't have expert knowledge. They're basically just whatever data has been fed into them. They're analyzing what the relationship is between words and predicting based on those things. But it's astounding what they can do with just that statistical modeling. But what they found was that while LLMs can excel at providing answers on well-trodden topics, which are represented in the retraining data, they stumble on specific, narrow, or contentious questions where there isn't a lot of data to support a prediction. Now, reasoning models will surmount this issue, ultimately, in my opinion, by being able to apply understanding, not just prediction, but understanding of concepts that have been retained in some kind of memory, apply them to smaller sets of data in these sort of narrow, specific regions, and make some intuitive leaps, let's call them, which the human brain does. So by analogy, it can say, okay, even though I don't have a lot of data to predict the relationship between these words, I can take these concepts and apply them to what I know about the data presented and make a jump, make a synthesis. It's a concept called synthesis, and a synthesizing mind is what we have. Once we get to AIs and models that can do that kind of intellectual synthesis, they will be much better than just statistical predictors.
So would you consider that a marker of achieving AGI is having that synthesis capability?
Yeah, absolutely. I don't know what, I also read in the news this week that there was somebody who had done a comparison of all the definitions that the major companies have of what AGI is. And they're similar in some ways, but they're also very different. And so there isn't yet a litmus test that's agreed upon widely about what AGI is. But I think that synthesis in inference is going to be an important marker. Absolutely.
Yeah, no, that makes a lot of sense to me. And I'm sure they'll announce AGI as soon as they think they can pull off calling it AGI. Just like how everybody calls, this is an agent. Oh, I'm sorry, this is our definition of an agent.
This is the North Pole.
Right. Exactly. Okay, so I'll wrap up with 2 short stories, with the last one being my favorite of the day. So first, I wanted to bring up a company called Cobalt Metals. All right. So I don't know why they chose Cobalt as their name, but for those of us who like looking, or familiar with like the
ancient history. Ancient history is what you're talking about.
Right. Mythologies and stuff like that. Kobolds are little spirits. All right. But what they do is they use AI to find precious metals or more critical metals for energy use, or the energy generation field. So things like copper, nickel, lithium, things like that. And they started off just in the, we'll find it for you phase, where it's surveying, research, things like that. But they developed an AI to take all of these different data points to find potential deposits. And so they found one. They found a huge copper deposit in Africa, and they needed money to go into the actual mining and development side of things. So they just raised about $500 million to go and do that. So Cobalt Metals is using AI to find the metals that will help power AI. and so I found it interesting that they went from simply the data processing side to the manufacturing side. So we'll see how well and how consistent they are in that process. And finally, my favorite story, smallest of stories, not a huge impact to anybody in AI or business or whatnot, but Google has just announced that they are accepting direct uploads of any file format to Google AI Studio. You don't have to go through Google Drive anymore. Sorry. That was just personally important to me, because I really hate the fact that I had to upload, like for us, a part of our process, had to upload a version of the transcript to my Google Drive to then be processed. Now, I can simply just upload it to AI Studio for processing. And that's it. Easy peasy. Not important in the grand sense, but those little conveniences or quality of life enhancements, that's where I get the most value out of when it comes into the AI realm. But that's all I got. Andy, do you have anything else that you want to cover?
I'm good.
No?
That's
all right. Awesome. So that's it for today. Please join us for the rest of the week. We got a couple of great shows coming up, and we'll see you tomorrow. Thanks, everybody. Bye. Aloha.